Hi, Integrated Math 1. Welcome to lesson E.1-5A. We're going to start talking about compound inequalities. Yeah, we're going to start talking about compound inequalities. We're going to start taking this to the next level. So if you have your book, we're on page 31. Otherwise, watch the screen, but I hope you're taking some notes there in your math notebook. So here's the deal. Hannah has some blue paint and she wants to lighten the shade. So she mixes in 1 cup of white paint. And you can see she did that. So here she had the blue paint. She mixed in 1 cup of white paint, but the color is still too dark. So it's still just a bit too dark for her. So she keeps mixing in 1 cup of paint at a time. Mix in a cup, another cup, another cup. And after she adds 4 cups, she decides the color is too light. She maybe went too far. So can you explain in words how much paint Hannah should have added initially to get the shade she wants? Go ahead, hit pause, just jot down some thoughts, hit play to keep going. So I don't know, maybe you had some different thoughts on this. There's a lot of different ways of looking at this. Maybe you thought she should have added 1/2 cup of paint at a time, right? Maybe she should have added 2 cups because we knew 1 cup was enough, and then maybe 1/2 cup from there. I don't know, a lot of different ways because I'm not sure what shade she's going for. I just know 1 cup was too dark and 4 cups was too light. So can you go ahead and represent that answer in part A, this whole idea like 1 cup was too dark, 4 cups was too light. Can you represent your answer in part A, what you said about how much you should have been adding with 1 or more inequalities? See what you can do. Hit pause. See if you can write out what you were thinking in words on part A with some inequalities. Hit pause, write it down, hit play to keep going. So I don't know what you wrote down because again, a lot of different ways of writing this. Maybe you thought that she should have added more than 1 cup. So if you wrote that, maybe you said, okay, well, she should have added more than 1 cup. So I would have said X should have been greater than 1, something along those lines. Or maybe you used a W for white paint. Do you want to use a W for white paint? Let's use a W. This isn't the only way to write it. Of course, there are other things you could have just said, oh, hey. So I'm just going to write W should be greater than 1. She should have added more than 1 cup of white paint. Maybe you said W should have been greater than 1/2. If you said should have added 1/2 at a time. I don't know, something like that. And then part C. Hannah is taking a look, and you can see we've got our different shades, right? The blue, the 1 cup, 2 cup, 3 cup, 4 cups, and you can see kind of that gradation there. Hannah decides that she likes the shade of blue that appears between adding 1 cup and 4 cups. So she likes these shades in between 1 cup and 4 cup. How can you represent the number of cups of white paint that yields the shades that Hannah prefers, that whole between 1 cup and 4 cups? Hit pause. See if you can write that down in some way, maybe an inequality. I don't know. Write it down and then hit play when you're ready to check your work. So this is what I'm thinking. And again, you may have written something totally different and that's okay. But my thinking is, okay, we know that she wants more than 1 cup of white paint, right? 1 cup was still too dark. So she wants it to be more than 1 cup. But she also, in addition to that, she also wants it to be, oopsie, just kidding. I'm using a W. She also wants it to be less than that 4 cups, right? I just used an M. Why do I keep writing an M? I don't even know. Let's use a W for white. I don't know what's happening there. So she wants it to be greater than 1 and also less than 4. So so I'm just going to write A. She wants more than 1 cup of white and she wants less than 4 cups of white. So I just wrote 2 inequalities and stuck an and in the middle. Seemed like an easy way to represent it. So we are talking about compound inequalities today. We're going to do some of this today. We're going to do some of this next time. But to get this party started, let's look at example 1 on page 31. How can you use inequalities to describe the set of numbers graphed below? You know, it's interesting because I actually see two inequalities on this graph, right? I see one that uses the -3 and goes off to the left. I see one that has an open circle at 2 and goes off to the right. So this graph actually shows the solutions of two inequalities, not just one. When this happens, it's called a compound inequality. So these two inequalities form a compound inequality. In fact, this is so important. I'm going to write a little definition and we're going to highlight it. A compound inequality is made up of two or more inequalities. So that's what I'm saying. I see two inequalities here, right? I see one with a closed circle at -3 off to the left, and another one with an open circle at 2 off to the right. So this is a compound inequality because it is made up of two or more inequalities. So how do we write that? To start, why don't we write down the inequality for each one? Okay, so we'll just take it one at a time. So I'm going to take this guy with the -3. I'm going to take this guy with the +2. And I'm just going to split them up for a moment here. And I'm going to write an inequality for each one of these. All right, -3, it's off to the left. So that means, since it's off to the left, that my x is the smaller guy. So this means that x is less than -3 because it has a closed circle. I'm actually going to say x is less than or equal to -3. All right, all right, all right. And that means for this one, I can see it's going off to the right. So that means x is anything that's greater than 2. So, oh, and it's an open circle. No equal to this time. So I'm just going to say x is greater than 2. So this one had a closed circle with my little squashed equal sign. This one had an open circle, no squashed equal sign. And it was off to the left, so we say x is all the numbers less than that number. This was off to the right, so we say x is all the numbers greater than that number. Now again, I have two inequalities here, right? I have two inequalities. So this means my compound inequality is x is less than or equal to 3, or it could be the other way, right? Or it could be x is greater than or equal to 2. So this compound inequality that describes this graph, I'm going to pull out my red pen here. The compound inequality that describes this graph is x is less than or equal to -3 or x is greater than 2. Yep, there it is. So I literally just took the two inequalities and I put an or in the middle of it. So I just wrote an inequality for each one and then I put an or in there. But you know I'm going to mess with you, right? Of course I'm going to mess with you. So I have another one for part B. How can we use inequalities to describe this set of numbers? Well, we're going to call these numbers x, and I can see they're between 4 and 1. I also see a closed circle at -4, and I see an open circle at 1. So I know that my solutions are greater than or equal to 1, right? Here's 4, -4, I should say, it's equal to, and I'm off to the right. So looking at this, if I just ignored the 1 for a moment, just looking at the -4 and where I'm heading off to the right, this tells me that I'm dealing with x is greater than or equal to -4. But if I ignore the -4 for a moment and I just look at the 1, well, it's an open circle, so it's not equal to. And from the 1, I'm going off to the left, so I would say the solutions are less than 1. So they're also less than 1. So they're greater than or equal to -4, but these numbers are also less than 1, right? So x is less than 1. So we're going to write inequalities to represent this, which we kind of just did. So again, if I'm just looking at the -4, it's closed and off to the right. So I would say x is greater than or equal to -4. If I'm just looking at the 1, it's open and off to the left. So I would say that x is less than 1. But because it's now, these numbers are in between. Do you see it's in between those guys? That means that the number has to be true for both of these inequalities, right? We said the solutions to the graph are greater than or equal to -4, but they are also less than 1. So we're not going to use the word or this time. We're going to use the word and. So the compound inequality that describes this graph is x is greater than or equal to -4 and x is less than 1. So because it's in between like that, those numbers are both greater than or equal to -4, and they're also less than 1. So that's why we have that and sitting right in the middle. You could also write it. Here's the fun thing. When you're dealing with and this is only true for this is only true for and, you can actually smoosh them together. So if you see the word and, you can actually smoosh them together and you write it like this. And I'll see if I can explain it a little better. Because I see the word and, these numbers are between -4 and 1. So I can literally write -4 is less than or equal to, because it's closed, x, which is less than 1. So you see how it goes from -4 to 1? So I'm literally going to write x is between -4 and 1. So this is another way of writing an and compound inequality. You can't do that for an or. You can only do it for the ands, but you can do it for the ands. So now that you've seen how this works, now that you've got the idea, can you go ahead and write a compound inequality for this graph? This is the try it problem, number 1. They're just underneath example 1 on page 31. I feel like I just said the word 1 a whole bunch of times. So go ahead, hit pause, write a compound inequality for this, and then hit play when you're ready to check your work. Well, first of all, I see -2 is open and I'm moving to the right. So I know these solutions are greater than -2. I also see 6. I see that it's closed and I'm moving to the left of 6. So they are also less than or equal to 6. Oh, because I use that word also, right? They're greater than -2, but they're also less than or equal to equal to 6. This means it's going to be an and statement, right? You see this and you're like, wait, that's an and statement. Other things, I can write this instead of words. I can actually say, okay, well, x has to be greater than -2. Less than, but x also has to be less than or equal to 6. And then I can just plop that word and right in the middle. So we'll do that. Now, do you remember? Since it's an and statement, you can collapse it down if you wanted to. So I could write it as -2 to 6 with my x in the middle. We always use less thans because we're going least to greatest. And notice, no squashed equal sign on the -2, little squashed equal sign on the 6. Both ways of writing this are correct. You could write it like this, that would be okay, or you could write it like this, that would be okay as well. Remember though, we only get to compact it like that. We only get to like squish them together for the ands. We don't get to do that for the ors. So sad. So let's take this a step further. We've been solving inequalities, right? We did that last time. We solved inequalities, treated it like an equal, treated it very similar to an equation. What you do to one side, you must do to the other, all that good stuff, and solved and got our x alone. And now we've been talking about compound inequalities. So that doesn't mean I have one inequality. We actually have 2. So when we solve a compound inequality, we're actually solving 2 inequalities. So let's solve this compound inequality. 5x minus 7 is less than 13, or -4x plus 3 is greater than 11. And then we will graph our solution. So first, I've got 2 inequalities to solve. Let's solve them. So let's start with the first one. 5x minus 7 is less than 13. I'm going to go ahead and add 7. Pardon me. going to go ahead and add 7 to both sides so that these lovely guys will cancel out. And of course, 13 plus 7 is 20. I will go ahead and I will divide both sides by 5. Now, I am dividing by a positive number, so I don't need to flip the inequality. Terribly convenient. And of course, that means those guys cancel out. And 20 divided by 5 is 4. So I know half of my compound inequality is that x is less than 4. Now, let's solve the other inequality. That's the deal with compound inequalities. You get 2 for the price of 1. So let's solve this inequality. Negative 4x plus 3 is greater than 11. Okay, well, to start, I'm going to go ahead and subtract 3 from both sides because that'll make those cancel out. And 11 minus 3 is 8, so that's convenient. Next, I'm going to divide both sides by a negative 4, but remember, when you divide both sides by a negative, you got to flip that inequality. So instead of greater than, it just became less than. Oh, and of course, these cancel out. That's why we did it. Goodbye, goodbye. So I now have x is less than negative 2. 8 divided by negative 4 is, of course, a negative 2. Now, there's an or in the middle of these, right? Or. It does say to graph the solution because I notice they both say less than. Let's see what happens. If I graph this one, I'm going to put an open circle on 4. X is less than that, so I'm going to move to the left. So open circle on 4, I'm going to move it to the left. For this one, I also need an open circle at negative 2, and I'm going to move it to the left because x is less than that. So here I have my 2 inequalities. Now, I need to put them on the same graph. So I have my little or, right? X is less than 4 or x is less than negative 2. But watch what happens when I put these together. This guy got absorbed by that one, right? And I'll show you what I mean. Let me grab my pen here and get a different color going. Negative 4 is over here. Negative 2 would be like right there. But if we draw an open circle and we color, it got lost, right? This one got absorbed by the other one. Oh, okay. So let me erase that because that looks bad. So because this one got absorbed by the bigger one, the final graph, since it's an or, is all the points that appear in either solution. Well, when I did that, it got sucked up. And so it looks like it disappeared entirely. My x is less than negative 2, like completely disappeared. And I just ended up with x is less than 4. Yeah. That doesn't always happen, but that happened this time. So again, the idea when you're solving compound inequalities is you solve both inequalities. And then, of course, put them on the graph for an or. They both got to be on the graph. Put them both on the same graph and see what happens. In this case, this guy got absorbed by that guy. That doesn't always happen. It happened this time, though. Go ahead and work out, try it problem number 2 over on page 32. If you're not sure where we're over at page 32. So try it problem number 2 just below the example we just did. Go ahead, hit pause to solve the compound inequality and graph the solution, then hit play when you're ready to check your work. All right, first things first, we got to solve them individually, right? We got to solve each inequality. So I'll start with this one. Negative 3x plus 2 is greater than negative 7. I'm going to go ahead and subtract 2 from both sides to make those cancel out. So I have negative 3x is greater than negative 9. Watch your negatives. I'm going to go ahead and divide both sides by negative 3. Oh, and because I'm dividing by a negative, I got to switch the inequality. Instead of greater than, it became less than. Of course, these cancel out, right? The negative 3's cancel out, which is why we did it. And negative 9 divided by negative 3 is a positive 3. So I have x is less than 3. Yay. But wait, there's more. I have a second inequality. So I'm going to go ahead and solve 2 times the quantity x minus 2 being greater than or equal to 6. Let's go ahead and kick this party off with some distribution. So 2 times x is 2x. 2 times a negative 2 is negative 4. And then I'll go ahead and I'll add 4 to both sides to cancel it out. But that means 6 plus 4 is 10. I'm going to go ahead and divide both sides by 2. And because I'm dividing by a positive, I do not need to flip the inequality. Of course, these cancel out, which is, well, why we did it. And I have x is greater than or equal to 5. Now, we've solved. Good job, us. Let us graph. Are you ready? I'm going to go ahead and put the both of them on the same graph. I could graph them individually, but you know what? I'm just going to put them both on the same graph, which means I need to make sure I can see 3 and that I can see 5. So I'm just going to kind of come back here and be like 0, 1, 2, 3, 4, 5. I'll keep going, 6, 7. I'll keep going this way too, -1, -2. All right. Let's graph each one individually. This says x is less than 3, okay? No squashed equal sign then, so an open circle at 3. X is less than that, so I need to color off to the left. So color to the left. Maybe this is a little longer than I needed it to be. That's okay. That's okay. So color off to the left. Put my arrow so I know it goes forever that way. And x is greater than or equal to 5. So I need a closed circle at 5. And x is greater than or equal to 5. So x is all the stuff bigger than 5. If x is greater than, that means I got to move to the right. Bigger stuff is off to the right. Okay, so I'm going to go off to the right again. Little arrow, going forever and ever and ever. Oh, look, we graphed it. Awesome. Okay, so our solution then, let me bring back my black pen. Our solution is x is less than 3 or x is greater than or equal to 5. You do need the word or in the middle. It is important to have that or sitting in the middle. Nicely done, guys. Nicely done. I'm going to erase this and you can see like the pretty like digital one that's like all nice looking and stuff. See the pretty one? Oh, it's so pretty. And look, there it's all typed like x is less than 3 or x is greater than or equal to 5. Look how pretty that is. So yeah, there we go. Well, as always, guys, I hope you found this helpful. Hope you found it useful. You got questions or concerns? Let me know. I'm around and I'll see you guys later. Bye.